We are at a critical point in time. The future of energy in Europe is being shaped right now.
Change to renewable energy.
To increase renewable energies.
Cleaner energies.
Wind and solar.
That should be the future for energy.
The operation of an electrical grid is a balancing act. The amount of electricity being generated must equal the amount being demanded throughout Europe 24 hours a day. It is the task of the transmission system operators to ensure this balance, because even small deviations from this can damage assets and cause failures. In Europe, all electricity is generated at the frequency of 50 Hz. Crucially, this energy needs to remain stable. If demand exceeds supply, frequency falls. Too much supply and frequency rises. Dialing up or down generation is one way to stabilize the frequency. Conventional generation plants power a rotor, a rotating machine that generates electricity at the desired frequency. Once in motion, the kinetic energy stored in the rotor keeps it running. Even when the plant powering it is switched off, it will continue to spin and create frequency until stopped by friction. This acts as a damper on the whole system. It's like having a longer balancing pole that helps to slow down and smooth out sudden changes. But with the transition to renewable energy currently happening across Europe, the nature of today's grid is changing.
Of course, it is a new challenge because the grid was built for dinosaur technologies like gas, like nuclear, like coal.
Renewable energy sources aren't connected to the grid by rotating machines, but by power electronics. These devices observe and follow the current grid frequency in order to inject the desired power. But analyzing the grid takes time, causing a delay that creates a drop in frequency. It's always one step behind. So, more renewable energy connected through power electronics means less natural inertia that helps stabilizing the grid and a drop in power quality. Maintaining the balancing act suddenly becomes much more difficult.
It's very important to be proactive.
Having more research, maybe.
We still need proper research.
Since January 2016, that's exactly what's being done with the European MIGRATE project. MIGRATE is the largest research program with transmission system operators' participation in history. With funding from Horizon 2020, Europe's biggest research and innovation program, 11 TSOs, 12 universities and 1 manufacturer are working together on innovative solutions to current and future challenges. They are paving the way for the large-scale implementation of renewable energy using power electronic devices for a stable, sustainable, pan-European grid. These are the projects, 5 technical work packages, and the results of their research. Work Package 1 identified and ranked the numerous stability-related issues of going from a power system driven solely by rotating machines to a system with an increasing amount of power electronics and developed ways to manage them. One solution is for some power electronics to not just observe and follow rotating machines on the main grid, but instead to create frequency themselves, to actively take part in grid stability, synchronization, and regulation, essentially forming their own grid. Simulations have shown that operating a grid with 65% power electronics is possible within the current framework. However, with these changes to the grid, how do we know if we're about to fall over? And how can we prevent this? That's where Work Package 2 comes into play. Using modern technology, they developed new monitoring and forecasting tools to provide real-time information on European grid behavior and stability so that we can better predict the power requirements in the near future. During tests in Iceland, they demonstrated that their tools are accurate, reliable, and ready for a live implementation. But stability isn't the only issue. Unlike with conventional energy generation, the volatile nature of renewable sources causes a drop in power quality, as does interaction between controllers. This in turn increases stress to machinery and network elements. Work Package 5 found methods to analyze and deal with these problems at the source. But even with lasting power quality achieved, all of this is uncharted territory. Traditional tools and concepts commonly employed are no longer valid and need to be updated or redeveloped. The safety of our power grid is of the utmost importance. Work Package 4 identified possible threats to the grid of tomorrow and developed guidelines and strategies for the design of new protection systems. With the last rotating machine gone from our grid, we need new control and management rules. Work Package 3 not only compiled such rules and made them available to everyone, but also tested them at reduced-size hardware and large-scale simulation. The 3 grid-forming algorithms and other solutions developed by MIGRATE represent significant steps in the transition to renewable energy. With further cooperation, research, and implementation in larger power systems, a stable pan-European grid powered solely by renewable energy is within our reach.
Okay, that's awesome. Keep up the good work.
It's a very important job you're doing.
Keep it going so we don't need to go back.
Of course, I encourage all scientists and all politicians.
We also need to work on a European level.
There is only way out, and it is through collective action.
We anyways have to work across borders.
Because climate change and stuff, that's something which will affect all of us.
If we want to save the planet for our future generations, it's important.
A lot of citizens interested in the topic, and let's fight together for that. Thanks.